I can only
Okay.
I can only record my end with my cameras. So
Okay.
Crime in progress. Recording in progress. Attention.
Yeah. Well, what, did you say crime in progress? I hope not.
I don't know. It's a quote from somewhere from a movie. I think crime in progress. I think it's future law enforcement. Crime in progress.
I
Okay.
had opinion to use crime in progress calling to 911 once. Mike, I have a quick question. Would
Yeah.
you object to me basically editing my part of the talk and making it a video that I can post somewhere else? I would basically use all 3 cameras and so on. Is there a
Oh yeah. Do whatever you like.
Thank you.
It's fine with me unless somebody else has an objection.
Well, if you're in a Zoom meeting nowadays, you may have to accept that you're going to be recorded.
Starting to look that way. Well,
I see several familiar faces here. Stefan Verbeek, hello. Jason Swanson, hello.
well, I say we go ahead and get started. We're rolling the recording. So if somebody's mic is making noise, I might cut your mic. Don't be offended. Thanks to Stefan Reich and Monica Anderson for agreeing to talk. This I've had the idea of having sessions for independent developers for a while. It seems like the world, partly because I think the world it's not really aware of us so much. So I'm not sure we have an identity really with the world, and so that's one of the motivations. Anyway, without further ado, why don't I turn it over to Stefan and get going.
Okay, thank you, Mike. Thanks to everyone for attending. The embarrassing truth is I am kind of improvising this. I waited for a script to come to me for the presentation. It didn't really come, but I have a website to show and I will explain the basic ideas. And I hope it gets the message across. So I'll share the screen, right? You see my screen, right? So the project is called Gazelle, which is a nice code name. It's been in development for a few years now. And right now I actually have a nice little team. It's not so small anymore. These are almost all the team members. It's my Indian student team. We're working for 1 month and it's really amazing. It's really fun. I did a similar thing before with a small group of 3 students. And yeah, that's the way we make progress right now. And yeah, what is Gazelle? BEA means nothing. It's just the latest installment of the project. But there is a thing called BEA objects. And these objects are the foundation of the whole thing. I thought, how can we make computers smarter? We need to put in not only code that they run, but we need to put in facts about the code. We need to put in reasoning about the code that the computer runs. So that's what I'm trying to do. And the thing with this database is that you can put in any object. It is like a NoSQL database. It does not require you to have any number of fields. You can define your own fields. Statement, let's say hypothesis. And the sun goes up every morning. Here's my hypothesis. And I can just create it. I just can add things to the database any way I like. Now I have this hypothesis here, and it's actually listed as being created by me. So it's immediately referenced to the user. All these objects have references to each other. That's very important. And now I can do things like use the text that I wrote and ask the system to interpret the text. The website you're looking at is obviously a work in progress. It has made layout and so on. But sometimes if we're lucky, we're already getting a parse of this. So this is not a good parse so far. I didn't find any good parse here. If you write something like the sun is a star, we will get a match. It will show the match. The sun is a star. So this pattern, the pattern was asterisk is asterisk, and it found this matched with the pattern. So everything we write in the system, if I write something here, anything, it will be interpreted by the patterns. So the thing I'm focusing on is having the system understand itself, not understand the world per se, but understand its own workings through the use of these hypotheses. And if it's a hypothesis about a software object, it can be checked automatically too. I have some examples here somewhere. Let's see. Here, if I put an uppercase string into some object, it will return the same string. That's my hypothesis here. And the object I'm talking about is just a simple character function that turns everything into uppercase. So this hypothesis will test if the object does what it does once it's actually being executed. Here's another hypothesis. If something is not referenced by anything else, it can be deleted. And what we always have to do is start with this general wording and make it concrete. So this can be linked. As I said, all objects have pointers to each other. This general description will be transformed into something concrete. For example, if we're talking about the objects in the database here, and then we define what being referenced means, and we test the hypothesis because it's not going to be true all the time. We have like 60,000 objects in here. Some of them are useful, some of them are not so useful. For example, if search engines click around on my site, they will produce new input. It's kind of funny because if you go to this query page, you will get lots of parses, and some parses are good, some are not good. But if you click on some of the sub inputs, it will store this as a new sub input. For example, here it can be deleted. If I click on process, I will in that moment make a new object with this part string. And that's what search engines do, because some of it is not a button, it's a link. It's not marked as don't follow. So search engines actually make new input all the time. But we can find that again. So that's why we need some garbage collection in the database. And I can't click on this. My browser is broken. There's it. So that's what this hypothesis is for, but it has to be qualified to actually work properly. So the general idea is to work in conjunction with the machine. I don't want to just give a task and have the AI do it. I want to get from normal programming to something smarter, programming that is more assisted by logic done by the machine. And then step by step, we go to the machine doing stuff itself. But it's way more based on normal programming than other AI approaches. It's basically a smarter, intelligent, smarter IDE. In this database, you can put code, actually. You can, that's the latest thing I built, and I'm very happy with that one. You can, yeah, which one is it? Layout is not good in my database, visual layout. It's a very complicated one. Is that one working? Let's see. Let's see. Yeah, you won't understand what the code does right now, but it's just a piece of Java code, or it's my own variant of Java, which has lots of shortenings and other constructs. And I put this code just in the database, and I say save, and it will immediately run it. Or sometimes I have to click, but usually it does this automatically. And it has made a new Java class, and it has loaded this code. Yes, custom code loaded. And that is really crucial because in the end, it also allows the AI to extend itself. There's a safety check on the code so that it doesn't delete the server. For now, the safety code is turned off, actually. Our safety check is that only master users, which is the main team, can put code in there. But we basically have a safety checker that just goes through this thing and says, are there any dangerous identifiers, dangerous function calls? And if they're not, it's okay. And we have things like checking for just a time limit. If the code evaluates for too long, it's canceled. It's also something I added to Java. So we can safely put code in there, and the code can be pretty random and can still be executed, which allows us to have the AI make code itself in the end. Because the AI I want is a code generator, basically. Either it's a code checker, it checks code for its purpose, or it actually makes its own code. So we are always combining language, which is English in this case, with code in smart ways. Let's see, anything else we have? Yeah, I'm still at the point where I can't show things working the way they're supposed to, but we are getting further all the time.
So is this like a large graph then that has
yes,
where each node has inputs and outputs? Or
well, the graph part is that I can just make objects that reference other objects. Here I can select this here, and I can find any object and make a link to it as a new database. I can put any name here. Let's say my object is an objection. I object to this hypothesis. Whoever made it, it never matters if this was made by a machine or made by a user. It exists. So I say objection, and I say because yesterday it didn't. It's probably a lie, but nothing stops me from putting it in here. So now I have registered this objection to the hypothesis, right? It allows the academic process to continue, finding out whether the hypothesis is actually true or not. And right now, I don't have a visualization of the graph. It's nice to look at, sadly. But you have to imagine that this object points to the other object.
So I've got a question, Stefan. You know, when I'm trying to understand a system, I kind of the first thing I look for is what are its inputs. So when it's running, so what have you what is a use case that you have in mind when this is running in production? It's going to get some type of input, and then it's got a function, and then it provides its output. And I can kind of see, I mean, what we're looking at now is the kind of like the guts of it. But I can't, I'm having a hard time envisioning, is it, so I think you mentioned it's a chat engine kind of a function, right? That's pretty much my question. So,
okay.
yeah, so like an example, typical use you've got envisioned, and how does it achieve generality? I can.
It's a tool, and I'm not focusing on any concrete application right now, but I make the tool. So wherever text appears, we have these patterns, and there's a way to combine patterns into a list and to make like one parser. Right now, we just have random patterns scattered, but we of course need a general parser that works for pretty much everything. That's not done yet. I will do that. But the general point is just to make programs smarter, just to have them understand what they are doing, if they are doing it well, what could be improved in their operations. And we all do it in language. If you have anything with...
Oops. I was curious, how does it understand the text? Like, are you doing intent or entity extraction?
Yes, that's another very important concept. It's called scenario. Maybe you can tell me if somebody else has like invented this. Let's see where it is. My search is not good. Let's look at the latest objects. Scenario. A scenario is a simple way of describing a situation. Where was my object? I can't find my object. It's embarrassing, of course. Here's one. Okay, there's a string x. X is in uppercase. I put x into this converter we saw, which makes uppercase strings, and this object returns x. So I just break it down into entities. This is an entity declaration. This is a statement, entities and facts. So this is an entity. This is a fact about the entity. This is another fact or something that happens, and this is another fact. And we could turn this also into an entity. There's whatever that is. And so now we have formally declared both the entities. And I don't define a specific language that you have to use. I just have this concept that every entity is properly declared and the facts are like stated one by one. So this kind of thing is what we work with. There is a computer there. I don't know. The light is off. I don't know. The computer is off. Let's say that's the computer at the light. If the light is off and the computer is off, it's another hypothesis.
So are you parsing this text and like converting it to computer code, or?
Yeah, I have to make the parts for that. For every random input, we make a scenario. A scenario is the intermediate representation we can work on. And from the scenario, we can do other things. We can compare scenarios. If you have two scenarios, you can map the entities of one scenario to the other entities of the other scenario and see if they are the same scenario. That's one very important operation. And also there's like an ontology, of course. A computer is a thing. You can test different hypotheses in the ontology. For example, is a computer a person? And then you look up your scenarios for person. The scenario for person is, I don't know, a person. What do they do? They talk. You say, the computer, does it talk? And if yes, you say computer is a person. Yeah.
That in your description pitch, you wrote that everything is connected to everything else, which I thought was pretty cool. So it sounds like that's kind of sounded like what you just described, I think.
Yeah.
How you seem to pick up a definition by its usage in these other cases in your graph database, I think. So if you've got a specific case, it sounds like, then you determine its characteristics, its context partly by connecting to what you described as everything else, which I kind of liked.
Can you dump your taxonomy so we can see what it looks like?
What is a taxonomy? Same thing as an ontology, or what?
Yeah, ontology actually is whatever.
I don't have that yet, actually. I don't have that yet. I don't have it. What I'm trying to do is to do everything that we need in this database here. I'm trying to add the natural attributes to it and the natural connections that it needs. If I have a hypothesis, what does it connect to? If I have an object that executes a function, what does it need to connect to? We connect it to these things, and then we're happy. and then you can make variations of objects and test these variations. You are looking at work in progress, obviously. I just, the thing is, I think I'm doing a very straightforward way, in a way. I'm just saying, well, how can we make the simplest database that contains reasoning, and simple also in the sense that people understand it. It's a limit to use this is really the requirement for using this is really low. The learning effort should be really low. Pretty much everybody should be able to look at it and say, okay, this is saying something about some statement, and I can click here and click there. The simplest computer representation of logical thought is what I'm looking for. And we can use all the power that Java has. We can put images and we can do anything. I really want to do also image recognition. And I need a system like this one here to reason about the image recognition. If I put an image recognizer in here, it's just another Java object. I can do that. And then the system reasons about whether the recognition is good and in what context it's good or not good. I want this meta level, the meta level that analyzes code much more than I want one individual smart algorithm. I love smart algorithms. We need smart algorithms, but I want the meta level of management of all these algorithms and management of the data and management of what users say about the algorithm. So it's basically a development platform more than it is actually an AI.
Stefan, can
And
you Stefan, can you ask it questions? Can you put in a query? Is there some technique to retrieve information by putting in a query of some sort?
Yeah, this is a page, but it's just not that far advanced right now.
Okay.
There's lots of things. How much is, it will find the pattern, which it doesn't do yet either, I think. It will match it to some pattern, and then it will run some algorithms and give a result. This is the page for this. Here, if you want to set it up like Google, where people can just type in anything, this is the page for it. And we are developing that.
You put in the fact that a computer has a light. Can you query it and say, does a computer have a light, or what does a computer have, or something like that? And does it pick up the fact?
Can I do it right now? No. Will I be able to do it? Yes.
Okay.
It's as I say, it's kind of embarrassing that things don't work yet, but they are all in my head, and I have to promise that they will work.
Well, that's the way it is. Yeah, I've got another question. I think one of your aspirations is to kind of fix what, I'm not sure how you put it, but fix what went wrong with Psych, because I think Psych pretty much bottomed out, and I mean the AGI community doesn't regard it as a big success. It probably is in some applications, but so what did you have in mind as far as kind of fixing where Psych went wrong? And down the road, it's envisioned.
The main thing is not having the specialized language, the Psych-L language. They had the specialized team of a few people who translated everyday knowledge into the Psych language, right? And the language is hard to understand, hard to learn. So they could never get the general population to fill their database. And also, I think Psych-L, the idea is that it's unambiguous, I guess. So that every term they create in Psych-L is precise, but I don't think that actually exists. So it's too hard. We have to account for the fact that every term we use is always can be ambiguous, and build that into the system. So and things have to be more local. Like you create some structure, some logic somewhere, and you always need the option modify it, to check it in a new context. Hopefully automatically or semi-automatically. But the process of making this should be way simpler than writing this specialized code. And stick closer to English, actually, or whatever language.
I think I understand. I mean, would it be fair to say, I mean, you're looking for it's symbolic based, and you're looking for a means of the user can input in natural language, and then from that your system has will have the guts to the functionality to create some generality.
Yeah, there are lots of these
just from their natural language input, and not from a script or not from a specialized language. So it sounds like you're envisioning a way they can just input natural language pretty much, right?
Yes. Yeah, there will be lots of these. Will be lots of little functions that little meta functions that do learning. Or, I mean, yeah. For example, you have a word that has multiple meanings. Okay. Or you hear something new, and somebody says my computer has I don't know, ray tracing X, and you wonder if it's the same thing as normal ray tracing, or just some example. And then you have a hypothesis, and there's little functions that check this, and you make up two scenarios. Is this new word that I heard, does it mean the same thing as the word I know, or does it mean something else than what I know? You check both of these hypotheses, which are also objects in the database, and they accumulate some kind of score, and one hypothesis is the one that probably wins out. And yeah, all these objects are supposed to have a life of their own through these little procedures that are running, where they are checked and improve themselves. Yeah.
Thanks.
And I don't know if I'm making sense.
I get the I can get the picture. I think
If we break it down into small actions, if it's a process of thought, if we break it down into small actions, we can understand each of these actions, make a procedure for it, and later the procedure that we make is also checked whether it works or not. But we just do all these little steps, and we just have a way of dealing with the uncertainty. If a system derives some objects from a base object, there's always the possibility it might be wrong. That we can backtrack later. We don't usually delete anything. We just create a new object, point to something, aside from the garbage collection stuff. But we also have a trail of what happened, of which procedure made which object, which always gives us the ability to check it later and, for example, downvote the procedure if it was not that good, or upvote it. So we see what we did and how we can do it differently. It's self-documenting, basically, or should be.
Does anybody else have questions? Okay.
Yes, I have a question. Are you storing relations always like a text wildcard? Is it always expressed in pure English?
I don't completely get the question. If the patterns are expressed with these asterisks, or
there was one pattern that you showed, which is a sentence which starts with does, or another pattern which is a sentence which has the word is in the middle, and then you had an asterisk before and after the is. So where the asterisk is, there's a part of the sentence which needs to be filled in, and that's then the relation I understand. So if you have a sentence with is, then it means that what's on the right, being the object, has, for example, the quality which is on the right side.
Also, the audio was a little bad right now. So yeah, we have the patterns, the syntactic pattern. There's another pattern with categories. So you can give a category name to this last thing, the left thing, and category name to the thing on the right, and they're connected to that syntactic pattern. For example, where's a nice one? Probably not finding this right now, but a new, yeah. Instead of the asterisk, you can put something in here, for example, adjective, or in this case, it's not a very interesting pattern. But if you say Joe plays some jazz, then you would have a pattern that's probably like this. Musician plays music. Okay, musician plays music is a very nice pattern. And it also created this asterisk pattern. So the pattern with the categories is converted to this asterisk pattern. And it should actually match right now. Where's my match? Where is my match? Place. I have to reload. Here, now the new pattern is asterisk place asterisk, and it made this match. So through the, it doesn't list the other pattern right now. But we can put categories here, of course. Did I answer anything that you asked?
Yes, that was very insightful. But I was wondering, if we talk in English, then the meaning is always very ambitious, meaning that one sentence can have 2 or 3 different explanations to it, depending on what the previous and next content is. And so I guess there's some need to first build up a content of the conversation which is going on. So if you just pick out a single question or a single sentence out of a text, then it's very hard to interpret it for its real meaning, because the sentence on itself is not an entire whole. It needs the context in which it is being spoken or written. And in that context, I was also thinking, if there's no need to first translate it to an in-between language. So on top, you have the English language, which is used by the human interface. But then beneath it, is there not some need to translate it to things like objects being things that have attributes and attributes having values? Or that you have things like a place or a time, and so that a context is not general, always valid, but only can be applied in a given context or a given situation, or even a local place or a single person?
Yeah, there's different ways how this is handled. If something has multiple meanings, it would branch out somewhere. Either there are 2 different patterns that match, and we can explore both of these, or there are 2 different scenarios that are attached. That's very typical, and we explore both of these. And that way we can also use the context. There's not an intermediate language, really, as I said, but of course, if you have this sentence, Joe plays some jazz, and you just have a representation of people in the database. Okay, objects that we're talking about, they are also in the database. Can also be put in the database. So Joe would have an object, okay? Maybe if the program knows somebody, for example, users are already objects in the database. A user is already an object. A user that registers here. Or we can also put a person in here, right? Let's say we call the, because we have this free-form database, type person, and the name is Joe, and he plays music or something. And now we have an ID. We get an ID for the thing, which is a number that the system makes. So we can talk about that. And we could, instead of this, what was the ID I had here? Instead of this, we say whatever, something, this, and we made it more clear. And it will be a pointer to the object. That's basically the intermediate language, is the objects in the database, which can be anything.
Is there always a single database, or are they also temporary databases which contain only information which is part of the ongoing conversation and which is dropped afterwards?
You could always make there's an operation of making new databases, of course, which you can do locally and everything. Of course, if you want to try some things and you don't want to pollute the main database, you would make a separate database, do the calculation there, and then see what came out of that.
Is there any other questions?
I have one.
Okay.
This reminds me a lot about Psych, for starters. I mean, but I also get a whiff of an earlier effort before Psych, which was from MIT. It was called AMORD. Let me see. It's spelled like this. That was in the 1970s.
Okay.
It stands for A Miracle of Rare Device. Is that visible? AMORD.
I can see it.
Okay, never heard of it.
Yeah, it's not very well known outside of MIT and outside of the 1970s AI community. But they created a programming language that allowed them to do roughly what you are doing, I think. And it's very Lisp-like because that was MIT in the 70s. But I looked at it very carefully back when it appeared, and I was very impressed by it back then.
Okay.
Okay.
I write it down here so I remember it. No, AMORD, rare devices, AMORD. Okay.
Any other questions? Well,
maybe I have a question for the people.
Okay.
I mean, unless the question is just, I mean, do you know, does it exist? You know, is this just a copy of something that exists? Because if it's not a copy of something that exists, I think it is worth pursuing. Because I'm not at a limit. I'm not at a point where I don't know where to go. I have a road of development ahead, so this will go somewhere for sure. So that would be
AMORD is dead. AMORD is
AMORD.
dead. It doesn't exist, so there's no competition there.
But it can still be looked at. I will look it up.
I have one, maybe.
Okay.
I joined a few minutes late, and I apologize if it's already discussed. What is the sort of end goal of this system?
Yeah, I thought I explained this. It's to understand language and to understand.
He was a little late, but yeah.
Yeah.
Okay, yeah.
A restatement would be good.
software.
I think we could all.
Okay.
I'd like to hear it again.
Okay. The goal is to make better software in the way that it understands itself and what it is doing and what it's supposed to do. Gazelle is a system about statements about things and a system of code that you can run. Any code you can put in here. The database contains Java code that is live all the time. So I can, through a web query, can do any request to any of the objects that process anything. So every object is a web service right away. And the database contains statement about, for example, these web services, and can reason about them. And you can add your comment to that. You can say, well, this function didn't work for me, and the system will understand what not working means and try to find out why or whatever. Support is also something that the system could do, support for users. Can you start with the simple stuff, but yeah.
Can you compare this to an expert system or a production system, as they're also known, where you have a number of basically what's called productions? I mean, Psych was an expert system. So do you have productions and a loop that runs over those productions and see what fits and then executes the right-hand side? I think that's what Stefan Verbeek was alluding to earlier.
Yeah, I mean, I've done lots of stuff over the years that I haven't showed right now here. For example, logic engines with lots of word processing, left-hand side, right-hand side, forward reasoning, backward reasoning. the whole shebang. I took Prolog and converted it to Java, and I just threw the syntax away. I made Prolog without the head clauses, just with English sentences. So it was kind of fun. It was a step definitely in the right direction. It's very similar to this pattern matching I have here now. But in the end, I was restricted by the reasoning algorithm. I always, I made these monolithic things. I made a parser for English with probabilities and like rules, probabilities, like a classic parser for the whole of the English language. But it quickly turned out that it was slow for complex inputs. I always found out when I make these monolithic things, when I make a super good logic engine or I make a super good parser, that they are too monolithic. That what I actually want is simple little objects like a pattern that can match input, and then I combine them in a more flexible way. So the patterns that are in the database combine themselves step by step to make a more flexible kind of parser or whatever. Because you need to have everything flexible. You need to put in a special rule for your parser if you have a special kind of input. And this is what the system is supposed to allow without killing you with complexity. Network of little operational entities.
Okay, anybody else, or should we move on to Monica at this point?
Well, I do have one question.
Jim,
sounds
like Jim.
Are you planning to give it more independence so that it can change data, or it can somehow evaluate different hypotheses that might create a conflict, and then try to come up with some change or a modification or a new result that would prefer to use?
Yeah, the system is supposed to do a lot of that. The more procedures we have, the more they will create new objects, and there will be just the different levels of trust in these procedures. If I have a completely untrusted procedure, I can run it because that doesn't kill me, but the result is not stored as a main object, or it is marked in a way that it is not affecting anything. And if I have a trusted procedure, the object that creates can just be stored like a normal object and actually used. There's always supposed to be many speculative procedures and established procedures, which both run and are also compared against each other. So whenever I propose something, let's say I propose a different procedure, just throw it in the database, the system tries it on some input and sees if it fares better than any existing procedure, whatever the procedure actually does. I want the laziest way of evaluating new code, for example. I throw the code in there, it's checked against some examples. And if it's good, it stays. That's why we need sandboxing. I have almost sandboxed Java. I mean, they say Java has a sandbox, but it's not the kind of sandbox that's useful. It's not fine-grained enough. So I'm almost there. I'm only not there for memory. If I write a procedure that eats all my memory, Java doesn't help me. But for endless loops, I have a solution. For deleting the hard drive, I have a solution that code doesn't do that. I'm almost there with the sandboxing.
Okay, I guess if that's it, thanks, Stefan. It was pretty good, and
thanks for not killing me.
Well, I guess at this point we can turn it over to Monica. So Monica, why don't you take it away, please? Thanks. I think you're muted.
Yeah, can you hear me? So for technical reasons, I'm going to do this different. I can't do a screen share because I'm on a stronger computer than the one that runs my Zoom meeting. But what I can do is this. So you may have to look at my screen. You have to magnify my screen, and you're not going to see me while I talk, okay? You may have to double click on my window to get the full screen.
I get speaker view on mine worked.
Okay, yep, that works. I'm going to be speaking all the time. So we, since there's not too many whatchamacallit, in the audience, you can interrupt me, and Mike can control that as needed. But let me get started here. So I'm going to talk about understanding machines. But before I do that, let's get to talk about myself, and then we can do a couple of procedural slides. So I'm Monica Andersson. I'm from Sweden. I'm a citizen since 1995. Got a master's degree. I know a bunch of human languages, and I've used 30 plus programming languages professionally. I started working in deep neural networks in 2001, which is kind of remarkable because that's 11 years before anybody else heard about deep learning. I worked at Google and several startups at the C level, and I founded Sentience Inc. in 2004, which is my research company. This will be different, and it will be colorful. The purpose of this presentation is that the success of deep learning since 2012 is a much bigger deal than most people realize. And I'm going to set that straight. Deep neural networks have given us a new and very powerful second toolkit for AI, where the first toolkit is our scientific understanding. AI epistemology provides many implementation hints, and much better hints than what neuroscience provides. Outline of the talk. I'm going to talk about fundamentals of AI epistemology for about half the time. Then I'm going to talk about organic learning, which is my new machine learning algorithm, and UM1, which is Understanding Machine 1, which is my cloud-based understanding as a service product line. For a warm-up, let's think about what it takes to understand a problem. Holly is this is basically grammar school level story problem. Holly is 4 years old. She has 3 boxes of chocolates, and there are 6 chocolates in each box. How many chocolates does Holly have? Well, 18 is almost correct answer. How did you know you had to multiply 3 by 6? How did you know you had to multiply? How did you know that the 4, her age, didn't matter? If you don't know the answers to these questions, it's going to be real hard to make a real AI. Programmer's understanding. If you're a programmer creating an airline ticketing system, you must understand tickets, canceled flights, and lost luggage. Otherwise, you can't write the code. If you're creating an NLP system for analyzing Japanese, you need to understand everything about the Japanese language. If you're creating an NLU system, natural language understanding system, that understands language the way humans do, then you need to understand everything about understanding. Note the difference. Understanding Japanese language structure versus understanding itself. You're going to get bored with me saying understanding, but that can't be helped. Almost nobody understands understanding. There's only a few people in the AI community that get this. But if you're doing natural language understanding or any other kind of modern AI, you must understand understanding because you will need to implement understanding as code. Let's talk about novelty detection. Only way to detect that something is novel is to remember everything you've seen so far, or at least everything important. Detecting something is new has enormous evolutionary advantage for instance, for animals. Novel things like other animals might kill you. If you have seen it before, it's probably harmless. So that's why we try to remember everything. It's harmless because it didn't eat you last time. Let's talk about dual process theory. It claims that there are 2 radically different processes in the brain. This comes from, among others, Daniel Kahneman's book, Thinking Fast and Slow, which is warmly recommended. But the theory itself goes back all the way to Darwin's second book, as I understand it. So dual process theory states that there is a low-level subconscious process that receives sensory input and discovers what is novel or otherwise salient, important. And then this is the understanding part. And then there's a high-level conscious process that reasons about the salient things that we understand. And let me prove it to you, that we have 2 mechanisms. Consider a European vacation. You want to plan your European vacation. You want to plan the sites, the events, the hotels, and the travel. And this is this form of slow step-by-step reasoning. All planning is reasoning. And you can break for lunch and then continue, because that's a lot of work. It might take several days to sort out what your vacation plans are going to be. Compare this to understanding your native language. You cannot turn it off. You cannot turn it off. Understanding is instantaneous. Doesn't take any time. Whereas reasoning, it takes days or weeks or years for certain people working with hairy theories and stuff. Let's talk about understanding our sensory input. Our eyes provide about 10 megabits per second as an information stream. This number is due to Hans Moravec. You are not conscious of your pixels. You don't see them. All you see is a summary of high-level summary of what you're seeing, so to speak. We can consciously perceive only about 100 bits per second. This is due to Csikszentmihalyi. The brain spends therefore about 100,000 times more cycles on subconscious understanding than it does on conscious reasoning. In my opinion, reasoning is overrated. When you enter this space, there turns out that there are a number of linked dichotomies. They are very similar, very parallel, and it's actually not a big deal if you conflate them a little bit, so I tend to do that. We have the reasoning versus understanding in brains that I just talked about. There's another one for general problem solving. People use either something called a reductionist stance versus holistic stance for problem solving. And they give you different kinds of answers, and they are differently effective in different situations. And the third one is that when we can use either reductionist symbolic logical reasoning or holistic intuitive understanding as strategies for creating intelligent machines. And that's where basically where we are, where we have to be very clear about what's going on. Let me talk about the two dirty words, as I call them, the reductionism and holism. They are basically important concepts in epistemology, and a lot of people think of them as derogatory terms, especially reductionists and holists are derogatory terms for many people. And that's very sad. They are extremely useful as terms. In my book, reductionism is the use of models. Now, you may not find this definition elsewhere, but it turns out to be a very, very useful definition. I used it for 15 years, and it's guiding my work. Models are scientific models, theories, hypotheses, equations, formulas, and computer programs. Models are simplifications of reality. If you have a model airplane, there is no airspeed indicator because there's no pilot. You threw that away when you built the model. The model has to be simple enough that you can put it in a computer and do some computation. You can't put all of the rich reality in there. So models require complete, good, and reliable input data. They require scientists to create the model, such as Newton created the model F equals ma. That's Newton's second law. And then we require an engineer to select the model, decide that F equals ma is what they want to use. And they're basing that on their STEM education. And both of these require first understanding the problem. Holism is the avoidance of models. Holistic agents solve problems directly in the problem domain without using models. They solve new problems by trial and error or other holistic methods. And I have made a list of about 13 such methods. They are the primitive model-free methods. And you can combine those to make many other kinds of systems and methods. And deep learning actually can be built out of my 13 methods. In general holistic systems and holistic agents, they remember what worked and what didn't. And so they pattern match new situations against prior problems to reuse prior working solutions. And this is very, very important. Holistic agents all learn from their mistakes. If your program doesn't learn from its mistakes, it is not an AI, in my humble opinion. It has to do that. That's very, very important. There's two processes going on here. One is modeling or called reduction. Depends on what level you're looking at, and application. Reduction goes from a complex reality to high-level understanding. So you're basically seeing the pixels on your retina, so to speak. You see the visual input, and somehow you discern that there's a chair there, and there's a cat on the chair. How do you do that? Well, you're doing it by the process that we call epistemic reduction. If you understand the problem enough to make a simplified model of it, then you can solve the model and apply the solutions back to reality. The answer is not to Holly's problem is not 18, it is 18 chocolates. The difference is the 18 is the result of running the model, the multiplication of 3 by 6. And saying it's 18 chocolates is taking that answer and applying it back to reality. This is also why apps are called applications, because they are doing exactly that. They're translating something of our current reality, of the user's reality, into a model, sending it off the backend. The backend computes it, presents it back, and we apply it back to reality. So application goes back from models to reality, whereas reduction goes from reality to models, if you will. Now let's look at human problem solving. Like I said, there was the reductionist stance and the holistic stance for solving problems, and they work differently. The battle cry of the reductionist is that the whole is equal to the sum of its parts. You are allowed to use logical reasoning in science. I prefer to use logical reasoning in science. Reductionist science can handle complicated problem domains, but it cannot handle complex problem domains. That's important to know the difference. Difficult problems may require partitioning into smaller problems, and then you can solve the smaller problems one by one and put it all together into a solution for the original problem. And you are allowed to do that because you believe that the whole is equal to the sum of its parts. You want to measure everything, you want to maintain maximal control of everything, and you expect correct results every time. These are all good stuff. These are all good things. Further, reductionists, they like optimality. They want the best answer. They want completeness, all the answers. They want repeatability, which is same answer every time. They want parsimony, which means do not waste resources. They like transparency. You have to understand the process. And they want scrutability, which means that the answers are explainable. You understand the answer. But if we want all of these, then NP hardness becomes an issue. That's going to be quite interesting in a moment. The holistic stance is the opposite. They start with their battle cry is the whole is greater than the sum of its parts. And they basically say, in complex enough systems, you cannot subdivide them into parts because the answer is going to be wrong. And that's true in many places where you have, for instance, bidirectional links between objects. If you sever one link, neither of them will work. It's not something that goes one way. Everything depends on everything else. That's kind of what holism means, if you will. You treat everything as a whole. And the holistic stance, with this you can attack many complex problems. Not just the complicated one, but the complex ones, which have these annoying dependencies on everything else. I have a video called Bizarre Systems that's on my Vimeo site, which you can look up, which discusses these problems in general. Difficult problems, well, the whole goes looking for more context rather than trying to split it up. The systems are generally fast, cheap, and out of control, which gives the heebie-jeebies to reductionists because they want to keep all the control. They will not delegate anything to a machine at that level. But these systems, they can handle incomplete or erroneous input, which means that garbage in, garbage out is no longer an issue. Very important about holistic systems. You know you have a holistic systems if things improve with practice. Your skiing downhill is holistic. Your playing tennis is holistic. You delegate to the lower levels of your brain the work needed to stay upright on your skis. You can't reason about it. That is too slow. You will just fall flat on your face. But if you practice enough, you're pushing the understanding further and further down your subconscious, and you get better at skiing. And that means that in machine learning, larger corpora are better, and everybody knows this is true. Creativity, aesthetics, and big picture thinking are generally only available to people working in a holistic stance. If you want to see a holistic creator in action, watch Adam Savage, especially the episode where he puts tennis shoes on a big dog from Boston Dynamics. NP hardness is a non-issue. because we don't care about any of those 6 advantages of reductionist systems, such as optimality and completeness. Traveling salesmen, they just travel. They don't have to have the optimal route. They're happy to do something that looks reasonable. Holistic systems can't even guarantee a correct answer. And then again, this bugs the reductionists because they want everything to be correct. But at least you can make an attempt. You can get started in situations where you can't use reductionism. I should say that anybody who has a choice between anybody who has a working reductionist solution to a problem would be a fool to use holistic systems. Because the reductionism, once you figure it out, is much, much cheaper, much faster, much more reliable. But sometimes you don't have that, so then you may have to go holistic. So full intelligence, in my opinion, is basically a combination of holistic subconscious understander and a reductionist conscious reasoner. You can't reason about that which you do not understand. This is very important. Holistic methods, they provide this understanding. The reasoning requires understanding, which means that understanding must precede reasoning. And there's many ways we can confirm that. For instance, if a lipstick is falling out of my bathroom cabinet, I catch it before I even understand, before I even notice it consciously. And so because the conscious self is living 500 milliseconds in the past, because that's how long it takes for the brain to process the sensory information and send it up to the consciousness. And so you can't play tennis if you have to think about how you swing the bat. You have to basically have to do it by gut feel. The only way to ski, the only way to walk, the only way to understand language is by gut feel. So we can now double our toolkit. Humans use holistic methods from birth. That's almost everything we do is holistically done, without models. STEM education, science, technology, engineering, and mathematics teaches reductionist problem solving methods and as a discipline, because it's something you have to vigilantly keep up, and you have to make sure your p-value is under 0.05, etc., and peer review, all of that stuff. But the deep learning revolution in 2012 made holistic methods available to computers. So, in my opinion, the remaining hard problems of the world, such as, I don't know, global economy, how the brain works, and drug interactions in the body, these are all complex problems that you cannot solve with scientific/reductionist methods. And I think of the 21st century as being the century where we're going to see the revenge of the holists. I mean, reductionism has ruled the roost since roughly 1600 all the way to 2000. And now it's time to get a different handle, so to speak, on the remaining hard problems. Suppose we want to build an understanding machine. If at first you don't succeed, lower your expectations. If you can't make an AGI, can we make just the understanding part? Nobody really tried it before 2001 when I started. And that's because of the introspection fallacy, which states that, which is basically that when you think about how you think, when you use your introspective capability, you can only see the conscious part. You can only see the reasoning that lives on the top of the understanding. And so therefore you miss the fact that 99.999% of what goes on is subconscious. Some people found this later, such as the deep learning crowd. They found it in 2006 and it became popular in 2012, which is basically the year that AI changed. How do we design such a machine? Well, brains jump to conclusions on scant evidence because scant evidence is all we will ever have. If you try to predict Apple's stock price a week from today, you don't know what's going on in Apple's boardroom. You don't know what Apple's customers are doing. You don't know what's going on in China. You don't know what's going on in the White House. Almost everything we do is basically, it's guesswork. Brains guess and they get it right most of the time because these guesses are based on experience. Let's make our machines do the same. Deep neural networks, like deep learning, are designed to learn, to guess, and to jump to conclusions on scant evidence. So is my stuff. Deep learning is not very scientific, and neither is my stuff. Let's talk about the evil superhuman AGI. All intelligence are fallible. That's probably my most important result. My most important result. The limits of intelligence are not technological. Limits are set by the complexity of the world. A reductionist logic-based superhuman, infallible, omniscient, godlike AGI is a 20th century reductionist fallacy, and you can quote me on that. You should ignore Skynet and other Hollywood AGI. I have a lot to say about how AI is going to happen. My system is called organic learning. My learner, it's my machine learning algorithm. It's called organic learning. It's a deep discrete neural network where you use discrete Java-based objects simulating neurons, and they have object references to each other, which simulates synapses. It's designed to learn any human language by just reading the text, 100% unsupervised learning. It can learn from continuous text stream as opposed to deep learning that uses batches of a few hundred characters each. Words each. And my organic learning learner learns any language in 5 minutes on a laptop. Good enough to score 99% of my test suite, for instance. It's a simple test suite, but it's roughly what you need when you're doing NLU. And this learner, it emits a competence, which is a file of kind of like a wiring diagram of all the neurons to be used by UM1. And UM1 is understanding machine 1. It is my cloud-based REST service, provides understanding as a service for a fee. It's a competitor to GPT-3 and Google BERT. You send in some text and you get back UM1's understanding of the text. This understanding may differ from yours, just like yours may differ from a coworker's, but it will still be useful in most apps that we want to create. Let's look at the UM1 algorithm. Remember, this is not the learner algorithm. This is the runtime algorithm, which already has the wiring diagram for instance, English or Japanese from the learner. So we have an input text stream. This happens to be from Jane Austen, which we used early on because it was out of copyright. We're reading a letter at a time, and the letter being read is looked up in a hash table, and the right-hand side of the hash table points to a node in the system. We create a new node when we feel like we have to, when we find a new letter, basically. And the node has targets, and it signals those targets. They are like axonal tree in brains. And those propagate their signal to other targets, but not all of them propagate. It depends on node state and other stuff whether propagation happens or not. Some nodes are known to be more salient than others, and the IDs of these nodes are returned to the API caller. That's the whole algorithm. So the UM1 API is called the number neuron API. This is a term I invented only a week ago. You send it some text and you get back something called a money form, and that's the only place I use my own name in the whole project. But it's a complex data structure. In the simplest case, it's just a list of numbers representing the salient concepts found in the supplied text. Each number is the ID of an activated discrete pseudoneuron. It only returns the more salient IDs. We sort them by saliency and truncate the list at whatever the user is comfortable with. Salience, again, is knowing what matters, and it's important in a learning system because you want to know what to learn. You don't want to learn everything you're given. You want to learn what's important. Organic learning provides a decent domain-independent estimate of salience, and that's a big deal. It works in any human language without algorithm changes, and it likely will work on DNA and music. Organic learning is very different from deep learning. It's fruit of a different tree than deep learning, because I started it without knowing what Hinton was doing and Hinton and Crowd were doing. A GPU or a TPU, a tensor processing unit, is not required. In fact, I can't even use them. My algorithm doesn't allow for that. You learn on a laptop, and you can run as on a Raspberry Pi if you have fewer than 30 million neurons. Organic learning uses no supervised learning, no stochastic gradient descent, no backprop, no link weights, arrays, linear algebra, tagging, grammars, dictionaries, goal functions, parsers, spiking, dropout, word-to-vec embeddings. statistical methods or output nodes. And if your favorite algorithm is in that list, I'm sorry, I didn't need it. And it uses almost no floating point. It had no floating point until 6 months ago. And it's unreasonably efficient. I mentioned that it learns 1 million times faster than deep learning, and I can expound on why it does that, but let's look at the simplest reason. It's 1 million times less energy while learning because it doesn't use a GPU. So deep learning was designed for images, which requires very expensive two-dimensional convolution in order to find correlations. That's what most of the deep learning process is discovering correlations in different parts of an image, for instance, matching towards other known images. Organic learning, in contrast, was designed for text streams. Text is a one-dimensional, so correlation discovery is a linear operation, and if you index it cleverly, it takes no time at all. And by the way, the indexing is inherent in the neurons. It's not a separate table. This took 16 years to develop, from 2001 to 2017, and I've had help from about 7 other researchers on this project. Thank you.
Thank you. That was really interesting. Have we got any questions for Monica? Yeah.
Yeah, I want to see it work.
But not a question yet, but it was a really good presentation. Thank you. I especially like the way you differentiated the symbolic and non-symbolic ways of approaching AI. And I think your framing of those concepts is spot on.
Thank you.
You said your service outputs understanding.
Right.
What do you mean by that exactly?
It is the thing that comes, I mean, you send in text to the server and it returns to you the moniform, and the moniform is the JSON structure. And the most important part of that is a list of numbers that represents the neurons that get activated when it read your string.
So it's kind of like an embedding, a word embedding.
Yeah, it could be, but it's not embedding in the Word2Vec sense. What is most likely is a repeatable transformer from text strings to integers where the integers convey. The integers are better than, for instance, count. Let's put it this way: if a cheap competitor wanted to copy what I'm doing, they would likely do things like, okay, each word in the dictionary, we just give it a number, and when you see it in the text, we return that. But that would be much weaker than what I do, because my stuff is context sensitive, so it gets different numbers. For instance, if you put the negation in front of a word, you get a different number out.
So is it a single number or
like a demo? Oh, go ahead.
One at a time, please.
Go ahead, Amal.
Okay. Is it a single number or is it a
list
vector over?
It's a list. It's a list of a user can determine. User can tell in the API call how long a list they're willing to accept. In the beginning, we used lists of 300 nodes for a typical tweet size message. But lately we have gotten the system so good, the salience is so good that we can basically classify tweets based on 39 integers. Say 42.
Got it. So it's a sparse encoding.
Yes.
Of the,
yeah. If you have a 200 million neuron system, 200 million nodes in your system, and the numbers are going to go from 1 to 200 million, and that's a very big vector, and you will return 39 of those are basically bits in the vector that are set, or 39 numbers that tell you which bits are set. So it is a very sparse representation, and that's very good if you're dealing with language. But we have to remember that the thing that does that you can't get with normal methods is that it does the disambiguation all completely automatically. And note, by the way, that it works equally well in French and Japanese. You just have to change the learning corpus. The system starts out empty. When you compile it and run it, it starts out empty. And then you have to feed it text in some language, and it will learn that language. And in a couple of minutes, it will score 100% on my test. And I can demonstrate that. I can also demonstrate UN1 being called from from my laptop.
Can you do that?
Yeah.
I'd love to see
Yeah,
it.
that would be great.
Okay, well, let's start with the UM1. I may have to hassle a little bit with my mouse here because I'm gonna have to go to the other window. Bear with me. So here we have a completely normal shell, C shell. And I'm running Python 3 in a Conda environment, and my code is called freetest.py, and anybody who wants to play with this code can ask me for it and I'll email it to them. I don't want to distribute it widely, but let's see what it does. So this goes to my cloud-based server and does the understanding. It runs 200 test cases, each of which has 6 strings. It has 1 string, which is a target, and it has 6 alternatives, and you're supposed to tell which one that most matches the target string. And can you see these numbers?
Font size.
I'll try.
Can you increase the font size, please?
That may not have helped. Okay, you can't see everything at once, but yeah.
That looks better.
Yeah. So it tells you what the time is. It tells you server uptime is 169,000 seconds. The corpus that we trained on, that we dumped this wiring diagram after 20 megabytes of corpus. That's like 30 books or something, like 30 novels. And it took only 2,192 seconds to learn that. 2,000 seconds to learn to get to 98.5% correct. It says in blue here, accuracy is 98.5. You can see the 3 red test cases that failed and which numbers they are, so you can go look at why they failed. But 3 out of 200 gives you 98.5% accuracy. It did 200 tests, no understanding failures, nothing was meaningless. And then I'm talking about, yeah. So how quickly did it go? It did this in, let me make sure I can see everything here. Yeah, it did this in 30,185 characters per second. So it understands English for purposes such as spam filtering or classification at the speed of 30 kilobytes, running flat out as a stream. And yeah, the whole thing took 2260 milliseconds. But the most important number here, in my opinion, is definitely that the corpus only had 20 megabytes and it learned it in 2,200 seconds. That's basically world record for learning, as far as I can tell. Now, my tests are not complicated. I try more complex tests and they will not have as good numbers. But what I have used is basically good enough for instance, for chatbots or for document classification or use classification and stuff like that. So
can we look at one of the tests just to
yes,
get a
we can.
good
One moment, let me pull it up. I have to warn you, if you have sensitive eyes, you may not want to look at the screen because this is not safe for work. This is Quora questions, and they are sometimes a bit questionable, so to speak. One moment. So this is a spreadsheet. It's a TSV file. First on the line is the truth, the correct answer. Which one of the, so basically you have 5 alternatives. The first thing you see here is there a reason why we should travel alone? That's the question. And then you have 5 alternatives. What is your New Year's resolution? Which liquid proof sealant is the best cost for value? Mumble, mumble, mumble. What is your opinion on PM Narendra Modi? These are made by Indian developers, I believe. Decision to ban mumble, mumble. Can I pass a urine test for meth in 56 hours? What are some reasons to travel alone? And that's what that's what the 4 means, that it basically, it's the fourth alternative starting from 0, which is the correct one. And the system gets those, but it doesn't look at the truth until later. And by the way, the truth is in the Python code. It is not sent to the backend. And so we have 200 lines of this kind where you have 6 strings on each line, and the system will classify them accordingly. And it, like I said, it fails 3 out of 200 after 2200 seconds of learning.
Is there an example where we have spurious data that will demonstrate that it's not only looking at keywords?
If it's only looking at keywords, well, that's the kind of effect you get if you don't train too far. So largely this is keyword based at this point because we have such a slow one, such a quick learning curve. Learning time, but we can run this on a larger computer and for much longer. I can run 200 megabytes of corpus on my Macintosh from 2013. I'm looking to buy a $120,000 computer which has 8 terabytes of RAM because the learner is RAM dependent. On the other hand, the runtime is not. But the learner has to keep a bunch of hypotheses about what makes a good reduction in the air, and those fill up the memory, and then once it finds one that it likes, it can throw those away, but temporarily needs a lot of storage. So yes, it's a very good question. I'm happy with it, even if it uses nothing but keywords, because this system, once you've created it, you can basically train it on the French corpus or the Japanese corpus, and it will still work. All you have to do is do the test cases have to be rewritten in French or Japanese. So it's a very
Monica, yep. quick question about the keyword aspect.
Uh-huh.
You have not told it to do keyword matching though. It's doing this context.
Excellent. Thank you, Michael. Yes. Remember that I'm reading character by character. So I don't parse the input and I don't store them as words, and the system does not in any way, shape or form compare strings directly. In fact, once you have read a character and you have tickled your input node, you can throw away the character. It's not used anymore. Everything is neurons signaling neurons, just like in the brain. And so the keyword match aspect happens at some level in the system, several neurons higher than the input. And that's just how the algorithm works.
I have more, but I don't want to hog the time here.
You have good questions, so feel free.
Awesome.
By the way, are we done with this screen? Can I turn on the learner and we can watch it learn English?
Sure.
Mm-hmm.
Do you have any papers that go over like more of the detail of how it learns?
I'm first going to compile this. Now I have an empty system. And now I'm starting the learning. This needs to be slightly larger to be readable. Hang on, let me see if I can do that.
It's readable, I think. It's fine.
I can see it.
Yeah. So I had to basically, normally I test every megabyte of corpus, but in 1 megabyte it goes to 98.5% or something like that. There's no point in, that's not very entertaining. So I put in an extra test every 100,000 characters. So the system reads 100,000 characters and it runs the entire test batch. And the test batch is run in a mode where it cannot learn from the tests. So you can use the tests over and over. So you use it again at 200,000 characters and you use it again and you go down and you can see here how the system learns. It starts at the 96% correct, which means the error is 4%. And then it gets closer and closer to the 0 bar, which is the vertical line as it goes. And here after 1 megabyte, we are at 99.5% correct. And that took us 46 seconds of learning to get to 99.5% correct. And it took 53 seconds of runtime, and the difference is basically the time we spent on those tests. And 200 tests goes very quickly. It does 500 tests per second. And it's learning currently at 19,170 kilo characters per second. Now it's going to wait. Now it's next number is going to be 2 megabytes, and it's going to take a while for it to work its way down to 0, and it might work its safe out of the 0 range. And sometimes this is a system from December, I believe, but it was suitable for this demo. Later systems have no problems going to 0, going to 100% correct. So we're learning English, and a megabyte is.
What are you testing it on? I mean,
I'm testing it on the
100% score and what?
It's a 100% score on the classification task among the Quora sentences we looked at a moment ago.
So you need a language, you need a corpus, and you need test questions. If I want to learn Japanese,
correct. If you want to do it in French or Japanese
trivia.
or Finnish, yes, you need test questions, and then you have to give me a chunk of text, and it's enough if I have 2 megabytes.
So I just make multiple choice questions of any sort.
Yeah, they are basically, you need to have every line has a target question, and it has a rephrasing of the target question. And then it has 4 confounding questions that are not the same as the target question. I have a Jupyter notebook that creates those out of Quora test data, which you can download from Glue.
So Monica, another question from Michael.
Mm-hmm.
The corpus that you're using to train this is not specifically, it's a corpus purely to learn English. It's just an English, it could be any corpus of English. Is that correct? And then you can
yes, actually, excellent question. Thank you very much for pointing that out. Yes, we are learning this corpus here. Actually, I can show you the script, see what we're talking about.
So there's no subject matter expertise on those questions in the text that you're using to learn in the system. Is that correct?
Nothing like that. So I need to scroll this thing. So here is the learner script that I just ran. It does some stuff. And then it basically, what you see here, it says minus learning digests are pause en, ask Reddit 5,000, dogs cats, ask Reddit 10,000, dogs cats, etc. And then after a while we get into Heinlein 6M. These are all what I called digests, and they are basically text in a slightly specialized format. I have the option of putting a tag anywhere I want. Turns out that I'm not using tag learning for anything. But this is basically what I learn. And the majority of what's going on here is the Heinlein 6M, which is 6 megabytes of Heinlein, starting with have spacesuit will travel, because we like Heinlein and we think that our understanding machines would enjoy those. The pause en is a very hard test case learning corpus, which is for the pause test. And I'm trying to get decent numbers on the pause test, but it is a much harder test. So I have failed so far to get it significantly higher. And dogs cats is basically the dogs and cats meetings at Reddit. So it's basically chat logs. Ask Reddit 5,000 is another chat log, and 10,000 is 10,000 lines of Reddit chat. So that's basically the mixture we're throwing at it. And we're doing it multiple times because it's so fast. We just, if it didn't catch it the first time, maybe it gets it the second time that reads the book, so to speak. So this is about 200,000. Sorry, this is about 200 megabytes of corpus. And it is widely distributed. I mean, it's nothing to do with the questions in the test corpus. So the questions are basically at the level of decent English and words, disambiguated words in context. That's what we're doing.
So the tests that you're using, that is very close to the natural language inference task in the NLP community.
Yes, excellent question.
Yeah, There are data sets available, for example, SNLI, Stanford's NLI data set,
Right.
which has this format basically. Have you tested on any of the open data sets?
Yes, I have. Like I said, this data set came from the GLUE data from the GLUE site, and there's also the Super GLUE site, which are basically generalized language understanding something mumble, I forget. And they are competitions for people who want to compare themselves to each other, how good they are. Unfortunately, a lot of those tests rely very heavily on reasoning. And this is a 100% understanding machine. It does no reasoning whatsoever. So the system is excellent at things like disambiguation, but it sucks at doing things like this follows that and so on. So that will come later. We're working on that. We know what we need to do, but we need this $120,000 computer to get there.
Got it.
I've got a question. How, it's not open source, I don't think. How are you protecting your intellectual property by a trade secret?
Yeah, it's basically the learning happens only at my site on my equipment, and that's why I want to have the equipment in-house. So the learner is the biggest secret I have, and it's about 12 to 16,000 lines of code. It could be shrunk down to maybe 8 or 7,000 lines of code. It's all Java. And the understander, on the other hand, is about 400 lines of code, and of that 90 lines is the algorithm. The rest is I/O. And so I have, in the cloud, I have the understander running 24/7, the UM1. And that part I will eventually have to sell because if somebody like Google buys this, they will want it on every machine in their cloud in millions of copies. So eventually I have to basically sell or open source the understanding machine, but I have, it's good for me to keep the learner itself and the learning algorithm secret, because that gives me the power to continue selling this stuff.
You didn't go the patent route at all then, I don't think.
No, because so AI is one of these things where if some big company wanted to use my stuff, all they had to do was read the patents and implement it. And that's not what I want. We couldn't check whether they use it in-house or not because it's there in-house. So the better deal is to basically do what I did, was create a RESTful server in the cloud and then charge people to use it. The server you're looking at so far is called a free server. It's always going to be there. It's always going to be free. It's always going to do English, but it will not do it very well. It's based on these corpora you saw. And if you want to do medical English, you're host. So you have to come to me and pay me extra to make a medical English corpus. And then I can learn up a machine for that. And that becomes the customer's property, but they pay extra for that.
Thank you. Any other questions?
Is there any structured output, like not only like one neuron as a result, but like a combination or extracting entities or stuff like that?
There are parameters that you can give. I told you that the moniform could be a very complex structure. So if you have a book which has chapters and paragraphs and pages, and you want to create a nested structure of arrays of arrays of arrays of strings, you send it into the UM1, it comes back as an array of arrays of numbers. So each string gets converted to a list of numbers in place where the string was. There's other options you can do to keep the strings around if you're too lazy to store them locally. And that structure is basically allows you to find the right paragraph with the right information in it. You can do better than that. You can ask for the results to be to be separated by character, so you can point to which character in the text that has the most is most about, for instance, coffee makers. I mentioned coffee makers because we did a test for eBay where we classified products based on the descriptions, and it worked really well, and we could highlight the words in users posting to eBay that indicated it was an espresso maker rather than a washer or a grinder or anything like that. So you can get per character output of what the meaning of the stuff is, and an entity extraction. We can do entity extraction. We can do better than that. We can do entity discovery, but that's slightly more expensive, and we are not ready to talk about that in detail. By the way, a fun thing, the system is completely thread safe. And when you're reading a book, you're starting up an internal structure called a reader. And we can have hundreds of readers. If we had a $120,000 machine, I could have 200 readers reading 200 different pages of Wikipedia at the same time, all combining their knowledge into one single runtime memory, one big memory image. So it's like having a brain with 200 pairs of eyes, reading 200 different books. So that's for speeding up the learning process. And then in the understanding machine, it is also completely thread safe. It's better than that. We know that the entire database, the entire data structure is read-only. So we can have hundreds of client processes sharing the same read-only data structure in the memory. Very efficient from my point of view.
Any other questions?
With that data set, it looks like a semantic similarity.
Yes, yeah. I mean, at some point, all NLP, all NLU is variants of classification. Until you get into language generation, classification is everything can be rephrased as a classification. Spam filters are classification between spam and not spam, and the spam goes to dev null, so to speak. So, but we can have 20 categories of news articles, for instance. In fact, I have not mentioned something. I didn't mention that I have a user interface paradigm called Maxwell. And in the Maxwell paradigm, you basically, it's a hack that allows you to pretend you're talking to a competent coworker. And you say, give me information about washing machines. And the system goes out and gives you information about washing machines. And then you look at it and say, that's about the washing machine. That's also, but that's not. So you just swipe left on the thing that isn't the washing machine. And you do a few of those. And now the system has been chastised and does better the next time. You say, do it again under the new rules. And suddenly you get a much better result. So this is basically meant for people, for instance, who are reading Facebook. Imagine if all the Facebook posts came in and you were deciding what you wanted to see and not Facebook. And I'm claiming that the Maxwell UI paradigm allows you to as an end user, to very quickly, within seconds, design exactly what you want your input stream to be like. And if it isn't perfect, at any time you can just swipe right or swipe left to improve or deprecate the semantics of a sentence as being part or out of, either being in or out of your selection set. And this is all handled by Maxwell. And the fun part about this is that Maxwell only needs you to run the understander once. Once you have understood all the input stream for the day, so to speak, then you can just manipulate the number sets using set theory. You don't have to actually go to the back end and do any more understanding. So the number neuron interface allows you to do almost everything you're doing with set theory. In fact, the Python program that I run to do the classification just uses set. It looks at the sets that come out of the 6 strings, and it finds the set that most closely matches the target string.
So you're not doing like cosine similarity. You're matching.
It's a kind of a cosine, but yeah, it's not, doesn't use computation of that kind, but it is using set theory. And the intersection size, yeah, basically in my system, the cosine definition is the size of the intersection of the 2 strings or the 2 sets of numbers, the 2 moniforms. If you intersect 2 moniforms, it tells you how similar they are.
Any other questions?
Yes, I have a question. If I look at the similarity between the holistic system and reductionist approach, like Stefan Reich has built this system, then there was before also this question about keywords. like one keyword is a template where the verb is in the middle of a sentence. Now, what I see both systems accomplish is that they both recognize the structure. The holistic system is learning it based on a corpus of existing text and by statistical analyzing and more or less also compressing all the structure that it finds. It recognizes that there are keywords like being and having. And if we look at the structure of the English language, then we see that almost all sentences are built around a verb which comes down to having something or being something. And if you would translate that to a reductionist approach, then you would have to build a system that builds objects and qualifiers and values and relations out of that. For instance, if in a corpus of text, there's a sentence that says Joe is hungry, or there's a sentence on the other hand that says Joe has hunger, which is basically the same meaning, then we would need a system to be able to recognize that. And if we would look at the holistic system, then we would see that the holistic system would not understand that those two sentences are related because they're in pure textually analyzed. They're different patterns. They're more or less used in the same context, but still they're different patterns. And that means that they also build different number neurons in UMI, while in a system that Stefan has written, he has to handwrite two different templates, one with being something and the other one with having something. Now, and then I come back to the question which I only earlier asked Stefan, that is there no need to build an in-between system like a language that is not English, but is very close to objects and relations between objects?
I don't need that. I should mention that I don't think of my systems as statistical in any way, shape, or form. Remember, I don't use floating point and stuff like that. The driving force in the learner is evolution. So this is an evolutionary system. Evolution is very important in the brain. There is a theory about how the brain works called neural Darwinism that says millisecond to millisecond in the brain, there is a competition between concepts and ideas. And the best concepts and ideas, they get to breed with each other and create even better concepts and ideas. And this goes on for a while, and every sentence you speak has gone through hundreds of iterations of, let's see, let me say this thing and let me think about how it sounds. And if it sounds okay, I'll let it go all the way out to the microphone. So that's how you're going to do language generation eventually. Is that we're going to run the neural Darwinism algorithm. And the neural Darwinism is already in the algorithm as we have it today, for the plain understanding, because I think it's necessary. It was necessary. This is the difference between reinforcement learning and my system, organic learning, which is in reinforcement learning, you basically, you encourage the stuff that looks correct and you discourage the stuff that doesn't. And my system does the same thing, but it also uses evolution to breed stuff that's better than what's coming in, that we started with.
Any other questions?
Not sure how much you can share about the learning algorithm, if anything at all. But I guess what learning principle is it closest to? Is it like is it Hebbian? Is it backprop, which you said it isn't? Is it logic? Like what's the high level base for the learning?
Well, it's all done using neurons, and so to speak. And one of the things about AI is that if you create an AI using some algorithm, and I say, now, can you do it in the neurons? like the brain does, because if it can't be implemented in neurons, it's probably incorrect, right? So I've implemented what amounts to, at some level of examination, not necessarily at the code level, it amounts to basically reverse indexing the way search engines do, because I use clever indexing to find correlations in the past. But those correlations are expressed as neurons and not as strings, because there are no strings in the system. Those were thrown away after you saw the input node.
Got it. In terms of capabilities of like matching the NLP leaderboards out there, do you think compute is the main bottleneck right now, or you think more algorithmic development is necessary?
We have plenty of algorithms that are in the lab, and a large number of those, they will choke after a couple of megabytes. When we turn on more advanced algorithms, they will consume more memory and more computation, and system will slow down. That's why we need 200 cores and 8 terabytes. So we expect that to bring us to the next level. We're doing okay. We are a few percent worse than state of the art in a couple of the tests. We are significantly worse on state of the art on the, for instance, the PAS test, PAWS test. And we will not touch the Stanford reasoning like things. We have no chance of doing those, because we don't do reasoning. It's all context-based disambiguation and so on.
Mm-hmm.
But we can do entity extraction and classification and all kinds of stuff like that, like nobody's business, very quickly. And quickly starting to matter, because people are now complaining that deep learning takes too much computational power. Somebody says that learning the BERT language model, it takes hundreds of computers running tensor optimized processing units in the Google Cloud, and they go for weeks to do that. And that's basically, okay, so I don't remember what the comparison was. They say something that's like more like Ireland consumes in a day or something like that. So it's quite expensive to run these learning algorithms. And
Monica,
yes?
It's one large transformer, 7 cars running for their lifetime.
Yeah, something like that. Yep.
No, it is that.
Thank you. Yeah, so we basically, learning and relearning is unavoidable in natural language understanding systems, because you can learn it once, like you spend all of this energy to learn it once, but then you discover a better algorithm and you want to do it again. And then language changes and you want to do it again. And somebody comes in, can you do it in legal English? Can you do it in legal Japanese? Can you do it in medical Finnish? And so you end up learning over and over again with slightly specialized corpora. And that's one of the business ideas we have, is that we're going to sell all of these English, medical French, medical Japanese, etc., special purpose corpora to people who need them. And they are optimized for handling the medical vocabulary in each language. And therefore, we need to train on that, because you got to have seen the word before if you're going to do any classification on it. Neural networks, machine learning systems in general, can only interpolate. They cannot extrapolate. In my video site at Vimeo, Peter Norvig makes that clear. He's got one of the videos on my playlist for holistic systems. Peter Norvig is a director of research at Google, and he basically shows that if you have a reductionist model, you can do extrapolation, but if you have a holistic one, you cannot.
Monica, this is Brett Martinson here. I just wanted to ask you, is there any possibility that they could be converted into a continuous learning system?
That's what it is.
It seems that you learn the corpora or all the words,
I learned from.
Then you deploy it.
Yeah, that is correct. I deploy it for running it in the cloud, but I can actually run the same tests on the learner. The learner has a built-in understander. It has to, And so at any point, you saw me run the learner, and the learner ran the test cases every megabyte, right? That's
Yes.
exactly what it's doing. It's basically running continuous learning, then it pauses it, passes all the threads that are learning, it runs the test suite, and it unpauses the threads that are learning, and they continue.
Yeah, but you were talking about selling it to people.
Yep.
When they go to then use it, would they be able to have their version continuously learning?
That is a further down the road question, so to speak. We first have to make sure that we can accept learning in the cloud in a way that people can learn their competences based on their own corporal. We won't pay people to be able to submit the big corpus and $2,000, and then out comes a competence, and the competence is loaded automatically into one of our UM1s and placed on the cloud, and now the customer that used the training, they can immediately test that one.
Right. Okay, well, thank you.
Mm-hmm.
How large documents can it process, say, for like semantic similarity?
When you have a very large remember, I can give you the nodes on a per character basis or a per paragraph basis or whatever. If you split up the large document, the smaller ones, you can say what the small units, how close to each other they are. So that's the way you probably would like to do that. If you send in a long email and you want to see how close is this to an Enron smoking gun email or whatever, something like that, we can handle email size messages, no problem. I mean, the learner runs continuously, so 200 megabytes is nothing. It's overnight run, 5 hours, it can run 200 megabytes. So if you want to do a document, if you want to see how close those documents are to each other, you're going to get 500,000 nodes out from the system. Nobody's done anything like that big so far.
This is a broader question. The Gary Marcuses of the world would say that language in itself is incomplete and without grounding.
Yes.
So it will always fall short. So eventually, after getting to a certain level of competence or performance, one might wonder, how do we incorporate other modalities like images that go with the words or sounds or other modalities to give the additional grounding? Is your system geared towards something like that?
No. I happen to believe a number of things about AI, for instance, that the embodiment argument is not necessary, the enactment argument is not necessary, and so on. We can learn everything from text, and the additional grounding in other modalities is not important. In fact, it's a royal pain. If Tesla just dropped their radar, and one of and they're just relying on vision, and one of the benefits from that is they don't have to do the unification of the different images. And I'm basically doing language understanding only, and I won't be bothered with images. I mean, that would typically require a deep learning system with the graphics processor, and I'm not interested in going that way. I have to admit, though, that I did a small project for a group that wanted to sell something to NASA, and that was for grabbing satellites that are spinning around, and I wrote a simple test program to see if I can detect which way it was spinning, basically simulating input from LiDAR data, and that worked pretty well. So I think that there is a chance that in the future I might want to try image processing or at least some simpler stuff besides. I mean, spreadsheets are multidimensional input. I could use a spreadsheet of some kind for as input and classify rows in a spreadsheet based on some learned criteria. But that's much further down the line, and I'm not interested in it per se, because language on its own, full-blown language understanding in any language on its own is $1 trillion business. I don't have to reach out from that.
Monica, in your presentation, you mentioned DNA as a possible language input. Have you had a chance to do anything with that?
I have not done DNA. I have not done MIDI either, even though I'm a musician. But it's certainly possible. I see no reason not to consider the fact that it doesn't contain anything about English. It learned English without the system itself knowing it was going to read English. And it could have been French. It wouldn't make a difference. It could have been Japanese. It handles the character set just fine. And if we just translate your MIDI events or the DNA basis into some kind of internal form, some kind of character form, you could translate the DNA proteins, sorry, not the proteins, the amino acids like like I don't know, whatever they are, into emojis and throw those in. I have a friend who does stuff like that. So you see an emoji stream, which is DNA data, and then it will basically understand that as a language. That would be quite hilarious.
How susceptible is this algorithm to adversarial data? Like if I replace all the A's with E's in the text, what happens?
Well, that would basically make everything more ambiguous. It would, garbage in, garbage out is not a big a problem as it is for reductionist systems. So it might very well learn that. But as a edge case, you know what ROT 13 is? You take every character in the alphabet gets pushed 13 steps forward. So the A becomes an L or whatever it is, and around the bend. And if you ROT 13 your text, your corpus, and you ROT 13 your test cases, there is no reason it wouldn't work.
I was talking about the way humans seem to understand or handle ambiguity, where we can easily gloss over mixed sequencing of characters in words and things like that.
Yes, typos.
Typos, yeah. Words in like poetry, so words are not in the right order.
Well, I say that if you want to learn medical HTML, you feed it medical HTML, and it will be able to tell the HTML from the medical stuff. It will understand both. And whatever. I mean, it's very much dependent on what you feed it in the training corpus. I forget what was the question again.
Oh, just ambiguity.
Ambiguity, yeah. That's what we do well. Ambiguity is what we do well.
Okay, good.
Because everything it's not words, it's basically concept in contexts. It's concepts in complex contexts, and I have said that so many times in talks that I don't even stumble on those words.
Any last questions? We got a couple minutes left. Anybody else?
What would be needed to answer questions like after processing the text, like what happened to Joe?
Yeah, that's reasoning, and we're not doing it yet. We are going to make our money on the understanding part because there's $1 trillion to be made there, and we would like to have a small fraction of that trillion. But reasoning can be built. It has to be built on top of the understanding. We talked about grounding earlier, and you can think of the salient nodes that we return to you as the grounding that you can then use reasoning on top of. And we haven't done any experiments with that. We don't have the resources. We are still focusing on improving the algorithms we have. But if we had a couple of million, we will certainly allocate several research and working on that, but we don't.
Okay. Anybody else? Got a couple. Well, if not, I guess we'll wrap it up. Thanks again, Monica and Stefan. It was really good. I lots to think about, and great questions too from everybody. As usual, I'm going to post the recording. So I guess Monica's making her own copy, but all I want.
Yeah, I should say that I have run 151 AI meetups in the Silicon Valley AI group myself. It's a meetup twice a month for 5 years. So I have a lot of experience with what I call AI improv, where I basically answer questions from the audience and throw them back at them and let them speculate. So that's my preferred mode of doing this, and I'm going to do it again. I'm going to reopen my AI meetup, and I hope that some of you might find your way there.
Well, if you have any of them online we could have cross.
Yep. You can cross post,
posting.
definitely.
Yeah, that would be nice. I think I'm kind of thinking we might have a live one, Lance. I don't know. Maybe we can.
Yeah, if anyone wants to
coming up this summer,
do the book review of Jeff Hawkins' 1,000 Brains, let me know, or Mike.
I would. I maybe we can go back to that pub we left 2 years ago.
Yeah,
whatever it was.
I'm curious if people would like to meet in person. I mean,
yeah,
I kind of would, but
I mean, I'd like to have, because online you get you can get a lot, you just can't get like you know, most of these people couldn't make it, but you know, so you know, we could do both live and online, you know, cross.
I'm looking for a live venue in the Bay Area that would cost me nothing but seat 200 people. So that's a pretty big order. I used to use Tech Shop and they were fine for years with that. And then they tore the building down. So I lost that. That's why I quit.
Oh, okay. Well, and also I'd like to hopefully do more independent AGI developer meetups like this in the future. So if anybody else wants to volunteer, by all means. So I guess that'll wrap it up then.
Yep. Thank you for putting this on, Mike.
Thanks a lot. That was great. See everybody later. I'm going to close it up now. Goodbye.
Thank you, Mike. Bye-bye.
Thank you. Thanks, Stefan. See you next time.